Okay, we have more factoring of trinomials here, but now we're going to have a leading coefficient. Rather than just beginning with x squared, there's going to be a leading number here. And I'm going to say when there's a leading coefficient, this is an important statement, when there's a leading coefficient, the trick that we were doing a little bit ago, which I'm going to call the multiply and add trick, or process, I probably should say instead of trick. I don't like that word. Process won't work. In other words, we're not going to find two numbers that multiply to c and add up to b. We have to rely on something else. So here we go with our first problem. We notice we have a 3 in front. In order to there is no GCF that will factor out of all three terms. In order for this to work, it's going to have to break into two parentheses, one of which has a 3 in it, the other which has a 1 in it. That way the F part of FOIL will work. Now as far as that 4 goes, notice the only multiplication problems are 1 times 4 and 2 times 2, neither of which are going to make that 13. Now 4, we have to try all these combinations, either 1 and 4, 4 and 1, or 2 and 2, until we find the right combination that works. And it turns out that it's going to be 1 times 4. That way, out here on the outer edge, notice that 3 times 4 makes the 12, and here's a 1 in the middle. 1x and 12x will add up to the 13x if both are positive. We're not looking for the 4 times 1 to add up to the 13. We're looking for this 1x and 12x adding up to the 13. You've actually got to be foiling as you're factoring when you're doing these problems. Problem number 2. We like that leading 7. We like prime numbers because the only way to break down that 7 is 7y times 1y. There are no other choices. However, for that 10, we've got choices of 1 and 10, 10 and 1, 2 and 5, 5 and 2. And you end up having to use your eraser a lot when you're working this one through. I generally don't try the 1s and the 10s first. I try the numbers that are closer together. Notice if you put the 5 over here on the far right, 5 times that 7 gets 35, which is way away from that 9. So I'm going to try the 5-2 combination. In the middle we get 5y, and on the outer edges there, 7 times 2 is 14. We get 14y. And if we have 14 positive 14 and negative 5, that will add up to the negative 9. So we want a 7y minus 5 and a y plus 2. Now, notice again, it doesn't matter which order you write these in, as long as the y plus 2 is together and the 7y minus 5 is together. It doesn't matter if you reverse the two parentheses. However, if you mess up the signs, it's wrong. Those middle terms won't combine together to give you that positive 9. Number 3 just appears out of order. It's not in descending order. So I'm going to rearrange it, write the 7x squared first, followed by the minus 18x, followed by the positive 8. And again, I've got a nice 7 out front. We like prime numbers. 7x times 1x is the way to start this. Now as far as that 8 goes, I don't want 1 times 8. 8 times that 7 on the outer edges would be 56. That's nowhere near that 18. I'm thinking 2 times 4. Okay, that gives me 28 and 2. Nope, 28 and 2 don't make that 18. So then I try 4 and 2. That gives us 4x in the middle and 14x along the outer edges. If they're both negative, they will add up to that negative 18. Now what we're doing here is a little bit of discovery learning. You've got to, through trial and error, try different numbers until you make this work. It's no good to look at the answer. It's no good to have anyone help you. You have to go through a certain level of discovery as you're working your way through these problems. Take your time. I know we want to rush through things, but this is something where speed will come. Right now, you've got to be checking that the F, the O, the I, the L are the parts of FOIL all work together as you're doing these problems.